Welcome back to the Algebra 2 Structure and Method textbook series. This lesson is written based on Chapter 9, Section 1, Part B, the midpoint formula. It's a continuation from the distance formula we had before. So in today's lesson, we're going to learn how to find the midpoint of a line joining 2 points. Before you start the lesson, you should know how to state and apply the distance formula, simplify radical expressions, and of course, graph points in the coordinate plane. We're also going to learn a couple of new words. Let's get started. To warm up, let's begin by finding the distance between 2 points. You should remember this from the previous lesson, so give it a try and see how it goes. My answers are coming in 3, 2, 1, now. Okay, hopefully this went well. If you struggled with this, go back and review our video from Chapter 9, Section 1, Part A, the distance formula. Now let's learn about the midpoint. So we learned about how to use the distance formula in our previous video. In a similar way, we can prove that the midpoint of the line segment joining P1 and P2 is given by taking the average of the x coordinates and the average of the y coordinates. So you end up with x1 plus x2 over 2, as your x coordinate, and then y1 plus y2 over 2 as your y coordinate. Let's try an example together. We need to find the midpoint of the line segment joining 4, -6 and -3, 2. First, I'll identify my coordinates. x1 is 4, y1 is -6, x2 is -3, and y2 is 2. Next, I'm going to substitute these into the midpoint formula one by one, and then I simplify, which brings us to our final answer, 1/2, -2. So you see, it's a fairly simple problem. You just have to find your coordinates and plug them in. For our second example, we need to prove that the midpoint of the hypotenuse of any right triangle is equidistant from the 3 vertices. Okay, so first, let's define equidistant. It just means the same distance or the same length. Now, it's just a fancy geometrical term, so don't be worried about it. Let's draw a right triangle POQ. Now, the midpoint of the hypotenuse is point M. Here's what we need to prove. OM is equal to QM is equal to MP. That's it. So let's get started on that. To make the math simple, I'm going to place the right angle of the triangle on the intersection of the vertical and horizontal axes, the origin. Now, I can choose my coordinates of Q, 0B, and P, A0 based on the fact that they lie on these axes. Now, keep in mind, you could put this triangle elsewhere, but this makes the proof simpler. I'll apply the distance formula to find the length of segment PQ. And I get that PQ is equal to the square root of a squared plus b squared. Look familiar? Now, since the midpoint splits PQ into 2 equal parts, we can say that QM is equal to MP is equal to 1/2 PQ, which is equal to 1/2 the square root of a squared plus b squared. Okay? Now, I'm going to apply the midpoint formula to segment PQ. And I get a plus 0 over 2, b plus 0 over 2, which gives me the coordinates of my midpoint, which are a over 2 and b over 2. Now, all that remains is to find the distance from O to M. Okay, so we're going to use the distance formula to find the length of OM. So after plugging everything in, I get the square root of a squared over 4 plus b squared over 4. I'm going to combine this into one fraction and then take the square root of the numerator and the denominator. I'm left with 1/2 OM equals 1/2 times the square root of a squared plus b squared, which is the proof that we wanted. So we're done. In our final example, we need to find the equation of the perpendicular bisector of AB, where A is at -2, 1 and B is at -1, 3. So the perpendicular bisector is a segment or a line that intersects another line or segment at a right angle. So here's the plan. I'm going to find the slope of AB and find the midpoint of AB, call it M. Then I'm going to use that to find an equation of a line perpendicular to AB. Remember how we find perpendicular lines? Passing through M. So let's start by drawing AB in the coordinate plane. Now, take a moment and calculate the slope of AB. I will show that now. So -4/3. Okay, now we need the midpoint of AB. 1/2 -1. So we have our midpoint, we have our slope. We need to find the equation that passes through M but is perpendicular to AB. Okay, so we take our slope, -4/3, and we take the reciprocal, so that's 3/4. And the point, we're just going to use M. So it becomes 1 plus y plus 1 equals 3/4 times x plus 1/2. Well, that's the midpoint formula in a nutshell. Great job today. Before you go, turn to your classmate and show what you know. Suppose we want to cut our line segment into 4 parts in the coordinate plane instead of 2. Could we use the midpoint formula to do that? I'll see you in the next lesson.